Dear students, let us we study about the topic silicones. In the last class, we have studied about the inorganic polymers. In the inorganic polymers, silicones are also one of the important inorganic polymers. Silicones are polymeric organosilicon derivatives containing SiO-Si linkages. These are also called polysiloxanes. General formula of silicones is R2SiO n times, which is written as on the silicon and oxygen, the backbone of the chain continues, and on the silicon you have the R groups, which are nothing but the alkyl or aryl groups. It may be methyl, ethyl, or even the phenyl groups. Hence, the silicones are also known as hybrid inorganic polymers. There are three types of silicones, namely linear silicones or straight chain silicones, cyclic silicones, that is a second class, and the third category is cross-linked silicones. I have shown here the linear silicones. They contain SiO-Si bond continuation in the form of a chain. The cyclic silicone, I have given an example like a trimer. In the trimer means the three silicon oxygen are there in the cyclic form like a benzene. On the silicon you have alkyl or aryl groups. Similarly, you can also have tetramer, pentamer, and also the hexamer of this cyclic silicones. The third category is cross-linked silicones. The cross-linked silicones are nothing but, so each chain, the one chain is connected to the another chain by a linkage known as SiO-Si linkage. So this linkage forms the cross-linkings, where R stands for methyl, ethyl, or phenyl groups, as I have already told you about this. Silicones have very high thermal stability. Hence, they are also called high temperature polymers. Such types are not found in organic polymers. That's why the advantages of the inorganic polymers. Now coming to the nomenclature of these silicones. The nomenclature is much similar to the alkanes. So we know the CH4 is called methane in organic chemistry. Similarly, if carbon is replaced by silicon, that is known as SiH4, it is called silane. So in case of the carbon compound, we write CH3CH3. It is called the ethane or methyl methane. Here it is written as SiH3. SiH3 is known as disilane. Similarly, we have SiH3, SiH2, SiH3. We have three silicon. Hence, it is known as trisilane. Suppose if H are replaced by some of the halogen derivatives, then we have, on the silicon, we have 2Cl and 2H. Hence, it is known as dichlorosilane. Because for methane, similarly, we have silane. Now, in this case, the silicon on the atom, we have two methyl groups and two Cl atoms are there. Hence, the name would be dichloro-dimethylsilane. Another example I have told you here, silicon is connected to 3Cl and 1-methyl group. Hence it is called trichloromethylsilane. Suppose if instead of the H, if OH is attached to the silicon, then suppose if it is attached to the carbon, it is called alcohol, like methanol, ethanol, propanol. Here we call it as silanol. So CH, instead of CH3OH, here SiH3OH is known as silanol. And on the silicon, if two OH groups are there, it is called silane diol. And similarly, if three OH groups are there, it's known as silane triol. So even in alcohols, we have dihydric alcohols and trihydric alcohols are less stable. Similarly, silane diol and silane triols are also less stable. Now we take other types, like the H are replaced by methyl groups. Then it is called trimethylsilanol. Now suppose if silicon-oxygen-silicon bond is there, then it is called siloxane. So we have the SiH3 two units are attached to the oxygen, hence it is called disiloxane. Similarly, we have below the trimethyl and here trimethyl, totally hexamethyl disiloxane. And these are the poly. It is polydimethyl disiloxane, and below one is polymethylphenyl siloxane. This is how the students, you must able to name these silicone polymers, and also some of the basic compounds that generally you come across in this. Now coming to the preparation of silicones. The preparation of silicones involves two stages. One is preparation of organohalosilanes, and second one is hydrolysis of organohalosilanes followed by polymerization. Coming to the first one, the preparation of organohalosilanes. This involves the two methods. In the first method, silicon is treated with chlorine to form silicon tetrachloride. This on further treatment with Grignard reagent to form organohalosilanes. The reaction is silicon. When it is treated with chlorine, we get silicon tetrachloride, SiCl4. When this SiCl4 is treated with RMgX, known as Grignard reagent, we get R2SiCl2 plus 2MgClX. There is another method of the preparation of these halosilanes, that is known as muller-rocho process. In this process, silicon is heated with alkyl chloride at 280 to 300 degrees centigrade under the pressure of 200 to 400 kilopascal using copper catalyst to get organochlorosilanes. In this case, the major product is R2SiCl2 and very minor products are RSiCl3. It means trichloroalkyl or aryl silane, and R3SiCl, it is known as trialkyl or aryl monochlorosilane, which are removed by distillation process. So the reaction is given. The second process is the hydrolysis of organohalosilanes followed by polymerization. This is in general to prepare the linear silicones, cyclic silicones and even cross-linking silicones. To prepare these linear silicones by the hydrolysis and subsequent condensation of dialkyl or diaryl substituted silicon chloride, and during this process the water is removed. I have given an example. Dimethyl dichlorosilane on hydrolysis gives dimethyl disilenol, which is unstable, and this dimethyl disilenol undergoes condensation, and during the condensation water is eliminated and we get a linear silicones. Now coming to the cyclic silicones. Like linear silicones, cyclic silicones can also be obtained by the hydrolysis and subsequent condensation of dialkyl or diaryl substituted silicon chloride. During condensation, water is removed. The same thing. Here, so instead of a linear chain, we get a cyclic product. I have shown a cyclic trimer silicon, the silicones. Similarly, we can also prepare by a similar method the tetramer, pentamer and also the hexamer. Coming to the third type, that is cross-linked silicones. During the formation of linear silicones, R2SiCl2, that is a dimethyl or dialkyl dichlorosilane, is to be hydrolyzed and followed by condensation. To form cross-linked silicones, RSiCl3, that is alkyl trichlorosilane, is to be hydrolyzed and further condensed. To stop the chain in silicones, the trialkyl or aryl silicon chloride is added and further hydrolyzed and condensed. Hence, in general, the trialkyl or aryl silicon chloride is regarded as a chain stopping unit. The dialkyl or aryl dichlorosilane is regarded as chain propagation unit, and alkyl or aryl trichlorosilane is regarded as a chain cross-linking unit. Silicone oils are linear silicones and silicone rubbers or silicone resins are cross-linked silicones. Here I have shown the diagram of the cross-linked silicones where the cross-linkings are there. Coming to the properties of silicones. Silicones are stable towards chemical reagents. They are not affected by weak acids, alkalis, salt solutions and water. They are highly stable up to the temperature of 200 to 300 degrees centigrade. They have low glass transition temperature, it's called the TG. Below the transition temperature, that is below the glass transition temperature, the polymer is rigid like glass, and above the glass transition temperature, the material is elastomer. They are good insulators and hence used in electrical appliances. These silicones oils are water repellents. This is because a silicone chain is surrounded by organic side groups. Silicone oils are resistant to oxidation. However, when heated in air, to 350 to 400 degrees centigrade, silicones are rapidly oxidized and this leads to cross-linkings. Low molecular weight silicone polymers are soluble in organic solvents like ether, carbon tetrachloride, benzene, etc. So, coming to the another silicone fluids or the oils. Silicone oils are linear polysiloxanes with an average of 50 to 200 units. The cyclo compound provides chain building units and hexamethyl siloxane controls chain formation. The viscosity of the silicone oils is about 30,000 times that of water and changes slightly with temperature. These are inert, non-toxic and have low surface tension. Silicone oils are used as insulating materials, as capacitors and transformer fluids. They are also used as hydraulic oils, compressible fluids for liquid springs and lubricants. The fluids are used as water repellents for treating masonry and buildings, glasswares and fabrics. So the coats, the raincoats are many times today they are coated with the silicone fluids. The fluids are used as anti-foaming agents and hydrophobing agents in sewage disposal, textile dyeing, beer making where it is used as a fermentation, etc. They are used as components in car polishes, lipsticks, shampoos and other cosmetic formulations. Coming to the silicone rubbers, these are also known as elastomers. Silicone rubbers have a very high molecular weight of the order of 10 raised to 5 to 10 raised to 7. They are produced by the equilibration of cyclic siloxanes followed by the hydrolysis of dimethyl dichlorosilane with potassium hydroxide. Here the filler-like finely divided silica is added to increase the tensile strength, gear strength and hardness. These silicone rubbers are extremely useful materials on account of their high thermal stability, low temperature performance, chemical stability, water repelling power and flexibility. Coming to the silicone resins. Silicone resins possess ring structures and have much higher cross-links density than silicone rubbers. The properties of resins are dependent upon R upon silicon ratio, where R is alkyl group. It is generally, this ratio is in between 1 to 1.6 in silicone resins. The silicone resins can be copolymerized with phenolic esters, epoxy cellulosic or other functional resins. The properties of these copolymers resins depend upon the nature of the condensing polymers and the degree of condensation. Silicone resins are used as electrical insulators. They are also used for lamination processes and for coating cooking pans, etc. So today we have the cooking pans covered with a polymer. So in this slide, whatever I have explained, the same things are there, like silicones are synthetic polymers with a linear repeating silicon oxygen backbone. Silicon polymers do not have carbon as part of the backbone structure. Silicones have high melting and boiling point. Depending on the number of repeat units in the polymer chain and the degree of cross-linking, 6 classes of commercially important products can be produced. Some disadvantages of silicones are increased costs and lower mechanical property values when compared to carbon-based materials. Some of the properties of silicones: they are highly thermally and chemically stable. They are all water repellent, used for low temperature lubrication. Silicone polymers are soluble in organic solvents. They are good insulators. They are resistant to oxidation. They have non-sticking and anti-foaming properties. All these things which I have explained earlier. Coming to the applications, silicones are used as greases, varnishes and lubricants. They are used for waterproofing in electrical condensers. Also used for various purposes at low temperatures. Used in medicinal and cosmetic implants because of low toxicity. Used for high temperature oil baths, high vacuum pumps, etc. Here I have shown the silicon-oxygen silicon skeleton, and we have polydimethyl siloxane, how it can be written, and also have shown about the silicon rubbers or silicon resins, where you have large cross linkings and also they have a ring structures in them. Here also I have shown the long chain and also the rings of siloxanes. Yes, in this slide I have shown. So the silicon oils, silicon rubbers, where they have an applications. So here what I have shown. So this is the one where these tubes can be introduced into the human beings, which acts like bones and also helps to travel the the blood. And here I have shown, so to manufacture the artificial teeth, so they take the prints of the jaws and based on that they prepare the artificial teeth. And the blue colored ones, they are nothing but they are the silicone oils. These silicone oils are liquids, and if you apply this, they have a waterproofing character they produce. So the silicones have very wide applications wherever you see. Even today, so if you want to have a waterproofing in concrete, they add the Dr. Fix-It. The Dr. Fix-It is nothing but it is a silicone polymers. Similarly, we have the waterproof raincoats. They are covered with the costliest one. They are covered with silicone oils. So even we have today the fuses. They are all made up of the silicone rubbers. So we have the silicones very wide applications on today. So students, go through these aspects and try to learn about these things.